Welcome to a new test and teardown video. This time it's a signal generator. I think this one is called a McGraw Edison, but it's also a Boonton. So I don't know exactly who is the main name on the list here, but at least this is what I see. If you Google this signal generator, it's called both McGraw Edison and then the standard signal generator 800. And I think we got a few different versions of this model because it has something to do with the frequency range. This one, as you can see here, the highest range is 470. And then the start is 25. So that is the range for this unit I got. But if you Google this, you can find other models also called 800. And they go to 960 megahertz. So how is that possible? I don't know. Maybe there's a doubler or some stuff like that. So, and it is definitely a carousel main switch. Feels like a very, very good and stable carousel switch for the main oscillator part. And then there is this fine adjustment. And there's also a very nice mechanical construction around this. There's a good stable, there's a really, really good feel about this. So super good mechanical construction. There's not a lot of features in this. Just a variable attenuator, and then you can see frequency deviation, so you can run internal, I guess, CV, that is of course no modulation, or external modulation, and then we got external modulation input here. I actually know how old this unit is. I thought it was actually older than 70, but it is from 73. See, there is a Danish note here, and it says something about using an external attenuator, and then there is an external attenuator nicely mounted here. But the funny thing is, this one is a 6 dB attenuator from Storno, so I think this unit was used in the good old days at Storno. It's a radio brand from Denmark, I guess, right? So, and this is a classic American product using the old American and extremely annoying connector today, because you can't really get this connector today. So, well, I just happen to have a few of these in my lab. As always, I think we should open first before we power up, because if I find broken parts by visual inspection, I can save a lot of damage. So I think this is my my first advice when you power up old funny stuff like this. Open, perform visual inspection, and then let's see what we do. So on the rear, there is not a lot to see beside a fuse and no info written here other than not a lot. I would expect this sticker to be a 220 or 30 volt information sticker, but that is gone. So definitely another good idea to open and check out what voltage range this one is set for. I also see this is not so good, so it was definitely dropped. Here is the front cover. Measurement division here. Very, very beautiful logo here. Yeah. That looks also a little bit with dents and stuff. But okay, it's 50 years old, right? So, I mean, it's okay to look a little bit like this, isn't it? Now we're inside this fantastic Boonton, and it feels like I have seen this before. It looks a lot like some other Boonton products I have been into lately. Wow, it is almost identical. It's the same kind of mechanical construction. Those DC filters here, they're very well made. Funny with the cables, it goes like around here and all that kind of stuff. But I think this one is a transistor unit, because look at all that. We got all transistors and modern technology. Wow, look at that. All transistor thingies here. But okay, this is from 1973. But still, there's a lot of really, really nice mechanical constructions here. Let me try and get a little bit of light down here so you can see. See, there's a little bulb right here where I'm pointing my finger. Can you see this little shiny object down there? I believe that is a bulb, and it is completely black. And what do you think about this kind of chain pull system? And then it goes to a switch, so there's some electrical alignments, calibrations, and all that kind of stuff as well. And then there is this beautiful gearing here. Output. Okay, let me try and swap this a little bit around. So the attenuator is not really an attenuator, but this is just a variable coupling. So you got this tube with the kind of pickup coil from the center of the oscillator output drive. So the longer you go inside or away from the source, of course, the weaker your coupling will be, and this way your output will be weaker and weaker. And this goes, as you can see, just if I let go, more or less it just falls down. It goes to that smooth. We got another bulb up here, and of course this meter is transparent, so that is, I guess, to let in light. What else did I find? I was having a little inspection round. Oh yes, another bulb here. So we got plenty of bulbs around everywhere here to make a nice and illuminated scale and scales and whatnot here. Okay, so this is modulation input, external modulation. Yeah, you can really almost read the schematic. Oh yeah, and here is this black cable. As you see here, there's a little multi-connector, and that multi-connector goes right here. And that power supply also look a lot like another Boonton unit I was looking at. What is that? Okay, that is the rear side of the fuse, obviously. But there is a tube, a 5651. That is a voltage regulator tube, right? Let me have a little. Yeah, it is. It is really nice and black. It has been running a million hours, right? I hope it still works. But then we see transistors as well. But when you, and bridge rectifiers and more transistors. So definitely a lot of low voltage power supply and a little bit of high voltage power supply. So maybe there is a single tube in there somewhere. I really want to open that one and have a look. Oh, this is classic Boonton. This we have seen before. So there's another little cabinet inside a cabinet. See, a doubled walled shielded case like this. Definitely good for isolation. But what we see down here, heater. So there's also a temperature sensor, and I believe there's also one more up here, right? I think it's hard to see. But we've also got some temperature probes, and we got some stuff down there. That is also a little bit interesting. Yeah. So let's try and see if we can open this one as well. So now we're deep inside this carousel. switch. And if you see here, we got the different inductors. That's part of the oscillator or the resonator. So let's see what happens if we select one of them. Let's go to this. So now we take this one and then click. Now that one is the selected one. And you can see it is right outside of this. This is the exit, right? Signal exit. And if I take the attenuator and move it all the way. Yes, now you can even see the pickup. Let me see if I can make this focus. Down there, right? See? Now we go all the way down here. Close as possible to the inductor. And that way we'll pick up most signal. Oh yeah, by the way, did I say tube? Yep, here you go. That is a Nuvistor. Tiny little radio tube that is right there. It's definitely in a little socket. So all you have to do is just pull it out. Oh, that's impossible to video. That is just beautiful. So that is what I think the voltage regulator tube was doing, just regulating the anode voltage for the Nuvistor to like 80-90 volt or something like that. So there's only one tube in this thing. So, but everything here looks so beautiful. There's no need to be sad and sorry about anything. I can't even find any bad corrosion or anything like that. See, it looks quite nice, all of it. So I'll just assemble this again and let's power it up. So I took out the power supply for a little bit deeper inspection. It's really beautiful. And of course all the low voltage stuff is transistors. So that is fine on this. I just believe this is a Zener pre-regulated for the little Nuvistor tube. But there's another little funny thing. If you see here the transformer, it is mounted in rubber. And it's actually really, I don't know if you can see this, but when I poke it here with my fingers, see, oh yeah, look here. It is very nice and soft. And that is of course to avoid mechanical vibrations, because transformers, they actually do vibrate a little bit or generate a little bit of a hum sound from them. And you don't want those vibrations to go via all this metal and into the oscillator part. So if all this is like vibrating a little bit, you can imagine, of course, you will be able to detect this if you just amplify or listen carefully enough. It will add tiny little bits of modulation, and for some kind of measurements it could be maybe detectable. So that is definitely why they did this. Yeah, it's very classic. I think we got here a little bit of tape mod. So that is the voltage selection, isn't it? Yes, it gotta be that. But I think I'm ready to power it up. Let me just put the power supply right here, and let's see if we are lucky. Do I feel lucky? Yes, I feel lucky. So this is going to be my first power up. First I will apply mains, and nothing happened. So I guess mains goes up and down this cable and into this switch. 12, 10, 9 watts. That's it. And I don't see any light in any of the bulbs. So that is... oh, look at that! What is that? That is signal. Hello. A 28 megahertz. And what do you know? Is that a surprise? I don't know if you can see this, but I am in 25 to 32, and down here it says 28 megahertz. Let me show you the proof. So it's not a lot of bull. Let me see. You see what I'm saying? Let's put it there. Ooh, we got 28.0 even. And it looks real beautiful. And sorry about this camera shaking around here. It's super annoying, I know. I will try not to do it so bad. And here's the yes. Well, that seems to be really nice. How about, is the output compensated for the different bands? So that could be fun to figure out. So now I put it like that. And let me try and change the band. And then exactly what I thought. So it knows this and it measures the power, because there is a power detector in here, and it is actually also in this output feed here, where it picks up the signal and then compensate the drive circuit and all that. And this way you get exactly the right output. And then it goes like that. Oh, nice. So that is 46. Let's 68 to 88. That is 76. And this is the 130 to 175. And oops, here the signal is lower. And I think this is the last. Oh, this is weak. But I think this is probably also how it's supposed to be, by the way. Why is this? That is not good. It says 12 megahertz, but hello? I am in the 400 to... Why are you doing this to me? So this should... It's difficult to read, right? But this should be 450. And... here is also 450. I changed the channel and the bits and all the resolution and stuff, because now I'm running quite fast compared to what the scope can do. So now we are at the maximum of this unit, and it should read 470. And yes, we got 470, and it's actually 0.00. I mean, would you believe it? Why can it be so accurate? That is a little bit amazing. I want to play with them. What is that? That is the deviation. I need to play a little bit with that. Here is the frequency 445.0, carefully adjusted, and then I just took a little hand radio here and put it for 450, and this, see, now we can hear what's going on, and this is the frequency deviation. And I can of course put it into CV, and then there is, it's actually this tight. There's not a lot of stuff escaping this box. I mean, that is a very... I am a little bit impressed. I mean, wouldn't you be impressed that there's not a lot that escape? Yes, and of course the external modulation also works. Let's try and see. And then I can adjust how much I want So that is funny. And there's also a sweep here. So then you can sweep filters and do bandpass filter curves and all that kind of stuff. So all in all, that is a really nice unit, and as you can see, it's still in the warm-up phase, so it's sliding a little bit here on the frequency. Let's get back here. See? And I need to find the right spot here, so a little bit critical. Yeah, so this is all I wanted to show you guys. I hope you had a little bit of fun. At least it was fun for me. So see you tomorrow. Bye bye.